X for X-rays, U for ultraviolet, V for visible light, I for infrared, M for microwaves, and R for radio waves. So these are the electromagnetic waves that form the electromagnetic spectrum. In this order is in the order of decreasing frequencies, meaning that gamma rays have the highest frequencies and radio waves the lowest frequencies. And something that we should know that is the frequency of an electromagnetic wave is inversely proportional to its wavelength. Therefore, with gamma rays having the highest frequency, it also means that they have the longest wavelengths. So therefore, radio waves have the shortest wavelength. So in this order of Zuvimar, this is in their order of increasing wavelengths. So if they form the electromagnetic spectrum and they are all electromagnetic waves, they all have common properties. What are these properties that they all share?
So electromagnetic waves have these following properties. They travel through space in the speed of light, which is denoted by c. They don't require any medium for transmission. They are transverse in nature, and they carry no charge. And one thing he's going to explain is that they possess energy according to the relation E is equals to HF.
E is equals to HF. This H here denotes the Planck's constant. Planck's constant. So the Planck's constant is what allows us to find the amount of energy contained in an electromagnetic wave. So as we said, in order, the highest frequency, lowest frequency. And according to this equation, we can automatically conclude that the one with the highest frequency will obviously contain the highest energy content. As he also mentioned, there is also C is equals to F times lambda. As I had mentioned earlier, frequency and wavelength are inversely proportional. Wavelength, this is its sign, as we had learned earlier in other topics involving waves. This F is for frequency, which varies from one electromagnetic wave to the other. This C stands for velocity, because there is also the equation of V is still equals to frequency times wavelength. So this C is not velocity for just anything, it is for the speed of light. Speed of light is 3 times 10 to power 8 meters per second. So you can always find the frequency using this equation, provided that you're being provided with the wavelength of the electromagnetic wave, because speed of light does not change. Alright, let us know some other properties. Okay, we can look at how we can apply these formulas that we have just learned in equations. Alright, we can take, for example, and say green light has a wavelength of 5 times 10 to the power negative 7. Green light has a wavelength of 5 times 10 to the power negative 7 meters. Calculate the energy it emits. Wavelength of 5 times 10 to the power negative 7 meters. Calculate the energy it emits. We go back to the equation that we had written. The energy it contains is E is equals to HF. And we have been given the wavelength. The wavelength, lambda, is 5 times 10 to the power negative 7 meters. we can see from here that it is not involved in this equation, but we also have another equation. For C is equals to F lambda. Speed of light is equals to the frequency of that electromagnetic wave times its wavelength. So we can always find the frequency. So the frequency, we divide both sides by lambda and make F the subject of the formula. We can find it by saying 3 times 10 to the power 8 divided by this wavelength that we have here, which is 5 times 10 to the power negative 7. When we do so, we will find the frequency. We will find the frequency, and we can just take it just the way it is and multiply by the Planck's constant. The Planck's constant is, at times it varies, but normally it is given as 6.63 times 10 to the power negative 34. When you do so, you will find the energy content of that electromagnetic wave, and energy, the SI unit is in joules. Therefore, the value you will get will be in joules. Alright, so we can move on to production and the detection of electromagnetic waves. We will start with, according to Zuvima, we'll start with gamma rays. Gamma rays, as we know, they have the highest frequency. Highest frequency will also mean that it will have the highest energy content. Okay, so gamma rays are emitted by radioactive substances. This results from energy changes occurring in the nuclei of these radioactive substances. The detection, they're detected by photographic plates and radiation detectors. Radiation detectors, we have an example of the Giger-Muller tube. The Giger-Muller tube is a type of ionization chamber, but it will be discussed later on in the syllabus, not in this topic. Gamma rays, they also have uses. Since they have the highest frequency, it also means that they have the highest energy content. This high energy content also means that they have the highest penetrating power. By having the highest penetrating power, they can be used in hospitals. They can be used in hospitals in sterilizing medical equipment, by killing cancerous and other malignant growths. Again, we can go back to the concept of the high penetration power, because they can be used to detect flaws in metals. They are the only ones which can do this because they have such high energy content that they are the only electromagnetic wave that can penetrate the metal surfaces. And we all know how hard metals are. So you can remember gamma rays for that.
Yes. So we go to the next rays, which are X-rays. X-rays are produced in an X-ray tube and are detected by photographic film and a fluorescent screen. The uses of these X-rays in hospitals, they use for cancer therapy because they are capable of killing malignant growth in body tissues. They are also used for controlling pests or germs by radiation. Another use, they detect forgeries in art, and they're also used in crystallography, which is the study of the crystal lattice of components.
Okay, we can move on to ultraviolet radiation. So ultraviolet radiation is produced by the sun, which we all know, sparks, and also mercury vapor lamps. It is also produced by, or rather due to, large energy changes in the electrons of an atom. This ultraviolet radiation is detected by photographic films, also by photocells, and it can also be detected by fluorescent materials. Fluorescent materials. So fluorescent materials, this is the spelling. Fluorescent materials are materials that are able to glow. So whenever they glow, you will know that they have detected ultraviolet rays. And it can also be detected by paper lightly smeared by Vaseline. So we can move on to ultraviolet radiation, or rather ultraviolet ray uses. So the They're used to detect forgeries, and also they are used, these materials, fluorescent materials, they can be mixed with washing powders. So when they are mixed with washing powders, they can be used in cleaning. So once those clothes have been cleaned, they are now hung out in the sun. So when those fluorescent materials are acted upon by ultraviolet rays, they will automatically glow and hence have an effect that causes the clothes to become brighter. And the ultraviolet rays are also have a high penetrating power and therefore can also be used to kill bacteria in skin treatment. Ultraviolet rays are also a source of vitamin D. Let's move on.
And the next wave is visible light. The major source of visible light is the sun, and other sources include hot objects, lamps, and laser beams. To detect this visible light, we have our own eyes and the photocell. And also photographic films can do the same. The uses of visible light is sight, photography, it's used in optical fibers which are in hospitals, and it's used in laser beams.
Okay, move on to the next one, which is infrared radiation. Infrared radiation is caused by or produced by small energy changes in the nuclei of an atom. Infrared radiation. So it is also produced by the sun, fires, or any hot body. Since it can be produced by any hot body, then we can also conclude that it can be detected by the effect of heat on skin. So you can even detect infrared radiation yourself. Also, it can be detected by a thermopile, also by a bolometer, and it can also be detected by a thermometer with a blackened valve. We all know black is a color that can easily, or it absorbs heat easily. So therefore, the effect of the infrared radiation, which goes hand in hand with heat, can cause the heat to be detected in the thermometer and thus detect infrared radiation. So we can also say that the heat, basically it can be used in household activities like cooking or heating food. Also agriculturally, it can be used in warming greenhouses.
Microwaves, we have the second shortest wavelength. And you see microwaves are produced in special vacuum tubes called magnetrons, or also in microwave ovens with a laser. And the detection of this wave is by crystal detectors and solid state diodes. The uses of this microwave, as we all know, we use a microwave cook or warm food, and it's also used in the military in radar communication.
Alright, now to the final wave of the electromagnetic spectrum, which is the radio waves. The radio waves, as we had looked at it earlier, it has the longest wavelength within the electromagnetic spectrum. So they are produced by oscillating electrical circuits and they are transmitted through antennae. We know radio waves from radios that we have all seen at some point, and the antennae is what transmits them. So they are detected by resonant circuits in radio receivers. Those resonant circuits are in all of the radio receivers, and they contain diodes and earphones. They contain diodes and they can also be detected earphones. Alright, so we can now move on to the hazards of electromagnetic waves. So as we had looked at it earlier, we had said that waves with high penetrating power can be used, but now we need to know that whenever they are used, they're used in controlled amounts such that they cannot harm those that are using them. Because as we had seen, if a gamma ray is so strong that it can be used to penetrate through metals, then it means that it is used in controlled amounts such that it may not bring any harmful effect to a human being.
These waves, when they are exposed to the human body,